Hello everyone, today let us see sample problem 3 from CBSE sample question paper. The question goes like this: a long straight wire of circular cross section of radius A carries a current I. The current is uniformly distributed across its cross section. The ratio of magnitude of the magnetic field at a point A by 2 above the surface to that of a point A by 2 below its surface is, and they have given 4 options. Okay, now what we have to do, we have to apply Ampere's circuital law. Ampere's circuital law, what is this Ampere's circuital law? Already I have explained in my YouTube. The Ampere's circuital law says that, you can see here, it is the line integral of the magnetic field around a closed loop is equal to mu 0 times the total current passing through the surface. That means in formula form, if you take, this is the Ampere's circuital law. Integration of b bar dot dl bar is equal to mu 0 I, or b is equal to mu 0 I by 2 by r for a circular loop. Okay, now coming to the point. Now let us solve this problem. So this is the problem they have given. You can see here, this is the problem. Now here it is the wire. So in this wire, the red one, you can see the blue color which I have shown here, that is the radius of the wire. Now they asked magnetic field at P2, which is A by 2 above the surface, and another point P1 A by 2 below the surface. That means if I draw this cross section like this, this is A. Above the surface means from here it is A by 2. Total distance of this point is A plus A by 2. That will become A plus A by 2. That is 2 is LCM. 2A plus A, that is 3A by 2. The distance of that is 3A by 2. Now they asked for another point which is below the surface at A by 2. That means this total radius is A. So half of the radius is A by 2. So distance of the second point P1 is A by 2 from the axis. So from the axis, P1 is at a distance of A by 2. P2 is at a distance of 3A by 2. So that is what I have done here. Therefore, as per the Ampere's circuital law, mu 0 I by 2 pi r. For the first one, what we have to take now is this one, mu 0 I by 2 pi. The radius for that is 3a by 2. That is the distance from the axis. So now here 2 and 2 will get cancelled. Mu 0 I by 3 pi a. Keep it one side. Now let's go to the point P1. So when you go to the point P1, now you can see already I told you P1 is at a distance of A by 2 from the axis. From the surface it is A by 2 means from the axis also it is A by 2 because the radius of the wire is A. So half of the distance from the axis, that is A by 2. So therefore for that, how much current, that is to be noted. Now what is Ampere's circuital law? You have to consider the current passing through that only. Passing through that only. Above that you cannot consider. So now if you see in this cross sectional area, now if you take A by 2, this comes this much only. So in this how much current flows, that is to be found first. Then you can apply Ampere's circuital law. How can we find? Now that is the problem now. So in our childhood, no, suppose if we have problems like 6 chocolates are 30 rupees, what is the cost of 3 chocolates? Then how we used to do? First we used to find the one chocolate price, that is 30 divided by 6, which is 5. After finding for one chocolate, you will multiply with 3, that is 5 into 3, which will become 15. In the same way, first this is the complete cross sectional area, that is the violet color. How much current is passing for 1 unit you have to take. After that, once you get for 1 unit, you multiply with the area of this green color, then you will get the current passing through the inner radius, that is A by 2. Okay, so now let's see, that also I have calculated and kept ready. I for an area of pi a square. I is for an area of pi a square. Therefore, for 1 unit area, you have to divide I with pi a square. That is what I have done here. So, I divided by pi a square. Then so that is what first we found the price of one chocolate. Then multiply with 3. Now I for area of pi a by 2 square, because this area inner one has a radius of a by 2. So inner circle area is pi a by 2 whole square. So whatever you get I for 1 unit area, this one you multiply with the area of the inner circle. I by pi a square is for 1 unit area. Multiply with the area of the inner circle, pi a square by 4. Pi and pi gets cancelled, a square will get cancelled, and what will remain is now I by 4. That is the current for the inner circle, that is inner radius. Therefore, now B at P1, the next one, that is magnetic field at P1, that is mu 0 I by 2 pi r. So I means here I by 4, which we got here, that I have substituted here. A is means radius is a by 2, substitute here, 2 and 2 will get cancelled, this will become mu 0 I by 4 pi a. This is the magnetic field at the point, that is the inner point. Now ratio they asked, B2 by B1, that is equation by equation, 1 by equation 2. Now go for equation 1. So this is equation 1, mu 0 I by 3 pi a, which is B2. Now with this we got mu 0 I by 4 pi a. So substitute both of them. Mu 0 I gets cancelled. Pi a will get cancelled. 1 by 3 divided by 1 by 4. Then it will become 4 by 3. So the option C is the correct answer. Now if you go up and see, so this is the question they have given. In this question, option C has 4:3. So the correct option, the ratio is 4 by 3 we got. So the option here is the option is C, option C. Okay, thanks for watching. God bless you all and grant you all great success in the coming exam. Okay, bye. So this is the answer.